In this video, I will be covering example 2 in the chapter circles. So let's begin by reading the question. Two tangents TP and TQ are drawn to a circle with center O from an external point T. We have to prove that angle PTQ is equal to 2 times angle OPQ or twice of angle OPQ. Okay, so it's pretty straightforward. The diagram has been given to us, and T is the external point from which tangents are drawn to a circle with center O. Our tangents are TQ and TP, and we have to prove that angle PTQ, right? So this angle PTQ is equal to twice of angle OPQ. This is what we are supposed to prove. So let's begin by writing our given to prove statements, and then let's look at how are we going to prove it. That's right. So TP and TQ are tangents to the circle with center O from external point T, and we have to prove that PTQ is twice of OPQ. So how are we going to prove this? My suggestion is always to begin with what are we given. So we have two tangents, right? TP and TQ, two tangents from an external point T. Therefore, theorem 10.2 is applicable to this. So I know that TP is equal to TQ, that is lengths of tangents. TP and TQ are equal, and also I know that using theorem 10.1, I know that using theorem 10.1, the radius OP is perpendicular to the tangent PT. So I think somewhere we can use this and prove the relation between the two given angles. And even though this might seem very complicated, it's actually very easy, because if you see, the triangle PTQ is now an isosceles triangle since PT is equal to TQ, right? So if this is an isosceles triangle, we know that angles opposite to the equal sides are actually equal, right? So somewhere we can use this, and we can also use the fact that this angle is a 90-degree angle and prove this. All right, so let's begin with the proof. I know that OP is perpendicular to PT, right? Radius perpendicular to tangent, or theorem 10.1. Therefore, angle OPT is equal to 90 degrees. But now what I see is that angle OPT is a sum of angle OPQ and QPT, right? This angle. So it's an addition of this and this angle, right? So can I express angle OPT as a sum of both the angles? Yes, I can say that OPT is equal to OPQ plus angle QPT, and it is equal to 90 degree, which we have already seen. We can also label this as 1. Now we are actually interested in which angle? We are interested in angle OPQ, right? So let's try to express OPQ in terms of QPT and 90 degree. I know that OPQ if I just shift QPT to the right hand side, so I know that OPQ is equal to 90 minus QPT, and this we'll need further, so we'll just label this as 2. Now let's shift our focus to the triangle PTQ. Now in triangle PTQ, I know that PT is equal to TQ, theorem 10.2, and that is lengths of tangents from external point are equal, right? Therefore, triangle PTQ is an isosceles triangle. Therefore, angle TPQ is equal to angle TQP, right? Angles opposite are equal, right? So we can label this as 3. But still we are not finding a connection between PTQ and OPQ, right? But there's another rule or property that we know about triangles, that is the sum of the angles of a triangle. And the sum of angles of a triangle is 180 degree, right? So if we express the sum of the angles of this particular triangle, then maybe we can get a connection, right? So let's see that angle TPQ plus angle PQT plus angle PTQ is equal to 180 degree. Sum of angles for triangle is 180, or you can also say angle sum property, okay? But from 3, I know that angle TPQ is equal to angle TQP, or in this case I've written PQT. So I know that we can actually write this, we can actually change this, and wait a minute, I can actually also see that somehow we are getting our QPT angle over here, right? QPT angle. So there we go, there is a connection between the two angles. So obviously I am interested in angle QPT, so I'll keep it as it is. And I will say from, okay, so I'm going to slightly shift this above so that we have some space to write. So I can say that 2 times angle TPQ is equal to 180 degree. But from 2, I know that, see, from here we can see that angle OPQ is equal to 90 minus QPT. And if we just interchange the angles a little bit, I can say that angle QPT is actually equal to 90 minus OPQ. Okay, so let's write it down. Let's say this is equal to 90 minus OPQ plus angle PTQ is equal to 180 degree from 2. Okay, now let's open the brackets. So 2 into 90 minus 2 into angle OPQ plus angle PTQ is equal to 180 degree, which is 180 minus 2 OPQ plus angle PTQ, which is 180 degree. Now I'll move the 180 to the RHS. So it will be subtracted and I'm left with 2 OPQ plus PTQ is equal to 0. Now if I shift this term to the RHS, what am I going to get? I'm going to get PTQ is equal to 2 times OPQ. Okay, so hence